In this lesson, we focus on math, MATH142, kinematics of a particle. Right, we shall be looking at projectile motion and other concepts that are related to that, and we move forward. Right, we're going to be looking at tutorial 2 and question 1. Show that the acceleration of a particle moving with constant speed is either zero, so we want to show the acceleration of a particle moving with constant speed is either zero. If it is not zero, or it is perpendicular to its velocity, hint, we shall use the fact that the velocity squared is the dot product of the velocity with itself. And that stated, we're able to mention the following, right, the following fact. So we proceed to analyze this particular question as follows. Right, so we have the following. To solve this particular question, as said already, we shall consider the fact that the velocity squared, the velocity squared is the velocity dot the velocity. And with this stated, what then are we actually able to do here? Right, so the velocity itself of a particle, and this particle moves. And if this particle moves, there are a couple of things that become very important. How do we therefore study the motion of this particular particle here? Right, so there are obviously a couple of things that remain critically important. It is the fact that we can be in a position to find the derivative of this particular particle here, right? And also, we can be in a position to study several ways of doing this particular question. And one of the ways we can use is the following. Is the fact that now V dot V can be seen as what? Right, so V dot V can be seen as, if you can be able to write the velocity vector as V1, V2, V3 dot V1, V2, V3, we can be in a position to find the dots. Product V1 dot V1 will be V1 squared, V2 dot V2 is V2 squared, V3 dot V3 is V3 squared. Right. But remember that the speed with constant speed. So we want to show that the acceleration of a particle moving with constant speed. So we've been given that V1 squared, V2 squared, V3 squared is constant. And that if it is then constant, it means that we proceed to differentiate both sides. Right, so we differentiate. We differentiate both sides to get squared V. Okay, if V dot V, then it's V1 squared, V2 squared, V3 squared. Okay, that's what we got. And we want to find the derivative of this. And the derivative of this is obtained as essentially the derivative of these both sides of this. So in other words, V squared is V dot V, which is actually V1 squared, V2 squared, V3 squared. Right. So now we want to be able to differentiate these both sides. So what we get? We get d dt of V. Right, so d dt of v. Okay, let's find the derivative both sides of this. So yeah, the derivative, the d dt of v squared would be d dt of v1 squared, v2 squared, v3 squared. Okay, let's find the derivative of these. Right, to find the derivative of this now, we proceed as follows. Right. We can be in a position to find the derivative of this if we consider the fact that we're going to use the chain rule. So the derivative of the v1 squared equals what? So it is 2v1. Okay, by using the chain rule, you bring down the 2, subtract 1 from the top. Then you find the derivative of the inside, which is dv1 dt plus. Then you continue to find the derivative of the v2 term. So you have 2v2, okay? Because it's like the derivative of x squared. You find the derivative of x squared, ddx of that. What is the derivative? It is 2x, because by the power rule, the derivative of x to the nth power is nx to the power n minus 1. So that is the sort of notation we're using. So that then in the end, you would have that it is 2v2. Then you find the derivative of the inside, which is dv2 dt, like that. Now we do the third one, 2v3. v3 dt. Okay, we get to this. We get to this. Now, upon getting to this, what then do we achieve out of this? Okay, but remember that this here is constant, right? Because particle moving with constant speed, and that suggests that this here is constant. Now, if we find if this v1 squared plus v2 squared plus v3 squared is constant, it means its derivative with respect to time is 0. 2v1 dv1 dt, 2v2 dv2 dt, 2v3 dv3 dt. Divide through by 2. v1 dv1 dt, v2 dv2 dt, v3 dv3 dt. Right, so this is what we're able to achieve. So what have we been able to achieve here? We've been able to achieve that v1 dv1 dt, right, with v1 squared, v2 squared, v3 squared equals a constant. Okay, then we can find the derivative. So it is v2 dv2 dt, v3 dv3 dt equals 0. Okay. What then is this? You recall. Remember the fact that the acceleration itself is the same as what? Acceleration is the same as dv dt. dv dt. If acceleration itself is dv dt, what then are we able to achieve out of that? Let's analyze these together. Okay. Acceleration is the derivative of the velocity with respect to time. Thus, velocity dot acceleration is equal to what? Right, so velocity dot acceleration is equal to what? If ever we are sure that actually the acceleration is dv dt, because what we have here, that this here equals 0, but simultaneously we know that the dv squared dt can be seen as 2 dv dt. We divide through by 2, and this is going to give us like dv dt. So dv dt equals 0 equals this. Yeah. dv dt. Right, so that in the end, the acceleration is this. Now, with the acceleration, this, because of the speed is constant speed, we get this. But we note that the acceleration is the vdt. Thus, now, if you then take the dot product of the velocity with the acceleration, it's going to be the dot product of the velocity with the acceleration. What is the acceleration? The acceleration is dv dt. Velocity dot, what is dv dt? Well, dv dt is acceleration, but dv dt is 0. Why? Because the speed is constant, so it's going to be 0. And therefore, this is 0. And this means that as a consequence, velocity and acceleration have a dot product 0. And they're orthogonal. And they are orthogonal. And they are orthogonal. Please look at this very carefully. Think about this. And let us know if you have a question here so far. What were we supposed to prove here? We're supposed to show that the acceleration of a particle moving with constant speed is either 0. So we've got that at this point. Hence the acceleration of a particle. Hence the acceleration of a particle moving with constant speed. Right? Moving with constant. With constant speed, right, with constant speed is either 0, is either 0. That is, the acceleration we said is dv dt, but the speed is constant, so that the derivative of a constant is 0, or perpendicular to its velocity. Or because if it is perpendicular to its velocity, then we find the dot product of this one with the velocity. And we've seen that this here is velocity. The acceleration itself becomes dv dt. Velocity dv dt 0. We have 0. So which means that v a equals 0. All right, so any question? Right, think about this question and make sure you're able to understand what is happening. This is start question number 1. We have been able to show whatever the examiner wanted us to show, or the lecturer wanted us to show here, we're supposed to show that the acceleration of a particle moving with constant speed. So, right, the acceleration is either 0. The acceleration of a particle moving with constant speed is either 0 or perpendicular to its velocity. So if the acceleration is perpendicular to its velocity, it means that they are orthogonal. And with this notion, we are able to, with confidence, actually allude to the fact that, again, we say thus, V dot A equals 0, and they're orthogonal. They are orthogonal. 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 Right, think about this. Make sure you understand exactly what we have done. Orthogonal means obviously they are perpendicular. So they're orthogonal. If you want to use the word orthogonal, we mean they are perpendicular. So what are perpendicular? The two things, right? So in other words, the acceleration of a particle moving with constant speed is either 0 or the acceleration is perpendicular to its velocity, so that the velocity and the acceleration have dot product 0. Okay, look at these and think about it and let us know if you have a question, and then we shall move on to solve the next problem. Right, obviously we have decided to spend a bit of time on the charts, and the reason for this is to make sure that we are able to interpret the chart questions. Obviously, they are essentially too many questions that are available at our disposal to sort of try and solve. And now we're spending time on the chart because the chart is equally important for us. So in other words, we actually obviously cannot actually manage to, even in the least amount of time, we can't manage to ignore these particular chart questions. So yeah, we're good. Simultaneously, we move forward to tackle other questions as well, because it is not only about the first question that we need to be able to solve, but we must be able to solve a wide range of other questions, and we proceed to take a look at other questions and make the most of the questions as well. We proceed to tackle the next question. Right, question 2, here it is. Right, question 2, it's about the acceleration of a particle traveling along a straight line is 8 minus 2s. So we are told here, we shall first obviously tackle part A, but we're told that in 2a, the acceleration of a particle traveling along a straight line is a equals 8 minus 2s. If v is 0, it's s equals 0, determine the velocity of the particle at s equals 2 and the maximum velocity of the particle. Right, so let us look at these and think about these very, very carefully, and make sure that we are able to understand exactly what is happening here. But now, if velocity is 0, if the velocity is 0 at the point that the s is 0, which is sort of the displacement is 0, then at this point we need to determine the velocity of the particle at s equals 2 and the maximum velocity of the particle. So there are two things we need to determine: the velocity of the particle, but also the actual maximum velocity of the particle as well. Let us reason this out together. Okay, we have a chance to solve this question, but the question is, what exactly do we do here? Because we have been given in 2a that the acceleration is 8 minus twice s, right? 8 minus twice s. And if it's 8 minus twice s, it is 8 minus twice s meters per second squared, which means A is dv dt. Acceleration is dv dt, but also v, it's ds dt. Okay, so yeah, we use these two equations. We use these two equations. We use the fact that acceleration is dv dt, but also velocity is ds dt. Right, and analyzing these right now, what are we actually able to achieve? We can be in a position to achieve the following. So now, if we are in a position to analyze this and look at what actually we are able to essentially obtain here at this point, we have exactly the following. Okay, I want us to examine this with utmost caution. With utmost caution. So now we have the initial condition. Right, we have the initial condition. What is the initial condition? Right, the initial condition is that time initially was 0, displacement was 0, also velocity was 0 in the beginning. Okay. And what then can we be in a position to achieve out of this here? Well, it means that whenever acceleration is given, we can replace the acceleration by what? By actually dv dt. But from these two equations, we actually can be in a position to obtain something. We can be in a position to obtain that we can make dt the subject in both of these equations. Okay, making dt the subject here, dv a dt ds v, like this. Okay, we have been able to make dt the subject in each of these particular cases. Right, and with this then mentioned, what can we be able to achieve? Okay, if dt indeed is dt, it means that we can have dv on a, which is ds on v. Which means that we have dv on a equals dv on a equals ds on v. ds on v. Like this, okay? So we have this kind of an equation that we can manipulate. Well, there are too many ways to solve this, obviously. But now if you cross multiply this, well, you can imagine sort of a cross multiplication. And if we do cross multiply, it means v is a s, like that. Take a look at this. Take a look at exactly this here. What is acceleration? It's 8 minus twice s. Okay, yeah. So that here we have exactly that. Ah, okay, wait. So V. Eight minus twice s. ds. Okay. This is what we get. Let us find the integral of this. So if you have v dv, v dv is equal to, yeah, you take the integral on the left, but also the integral on the right. So you have 8 minus twice s, the s, and you apply the integral there. Determine the velocity of the particle at s equals 2. Right, so you're going to do that. Okay, let's find the velocity here. The velocity of the v is half v squared is equal to the velocity of the integral of 8 is 8s minus 2s squared on 2 plus c squared 16s. Oh, okay, check. Fine. So this one, okay, now this cancels out, but you can multiply, it cancels out, the 2 cancels out, but you could multiply by the 2 here so that it becomes still twice s squared twice c. It gives us sort of this equation. It gives us exactly this particular equation. Right. So the initial conditions here that we got. So we've been able to achieve that v squared is 16s twice s squared plus twice c. At the initial conditions, v0, s0. Okay, if v is 0 and s is 0, so it's going to be 0 squared, 16 by 0, 2 by 0 squared twice c, 0, 0, 0, everything 0, twice c. This means that the arbitrary constant c of integration is 0. C is the arbitrary constant of integration. Right, so in each case, this is 0, which means v squared 16s 2s squared plus 2 times 0, which is 16s minus that squared. Right, so get this. We get this. Okay, because now then c is 0, so we get this. But now then we come to this point. We need to find the velocity of the particle at s equals 2. And then we shall be able to get the maximum velocity of the particle as well. Right. 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 We have exactly the following. Let's do this. So if we have that, v squared, 16s minus 2s squared Right, so yeah, when f s is 2, which means you have 16s, you put a 2 here, because S is 2. So wherever S is, you put 2. Ah. Sixteen by 2 is 32 minus 2 by 4 is 8. V squared. 32 minus 8. Right. So if we subtract from 32, we subtract 8, we get a 24, it appears. And with that, we have V squared equals 24. Take the square root. Okay, if the square root of V squared equals the square root of 24, V equals, you take the square root of 24. Okay, the square root of 24, I know one can say it is the same as 4 by 6, which is, 2 to the square root of 6, in the sense that it is the square root of 4, the square root of 6, 2 to the square root of 6, approximately what? In decimals? Check. So we'd have the following. Didn't load the calculator. Can I just get it once, please? Okay, let me just get the calculator, please. Getting the calculator. Just to make sure that we're able to confirm our calculations. Right, so we have the calculator. Let us do the calculation and say, for instance, square root of 24. Which is 2 to the square root of 6. The case you simplified it, which is 4.89. 4.898979. So that would be exactly 4.90. So in other words, we then say it is 4.89. It's 899. Can write like that. 4.899, which can be written according to the answer, so the velocity, therefore approximately 4.90 meters per second. Meters per second. Any question? Any question here? Exactly. Right, so it's something you need to think about. Right, it's something you need to actually think about. Right, it's something you need to ponder on and try to sort of make sense of this. Right, so the couple of things obviously you need to actually at this point be in a position to take into account. But what would the maximum velocity be? What would the maximum velocity be? Okay, so in 2A, well, we're still doing 2A. We know that V squared equals, V squared is 16S minus that, 2S squared. 16S minus 2S squared. You see, the velocity itself can be seen as, because it's v squared, you can take the square root here, you can take the square root there. 16s minus 2s squared. Well, in principle, it can be plus or minus, depending on the case. So the velocity is plus or minus. Take a look at that. It's plus or minus 16s minus 2s squared. Okay, if the velocity is this, if the velocity is exactly plus or minus that, but we want to get its maximum velocity. So this is quadratic, and you can be able to analyze that. And a couple of ways, obviously, that can be used to reason this out. The couple of ways that it can be used to reason this out. Okay, so you think about this. All right, you think about this. We can just use the derivatives, but also you can be able to use techniques of functions. Okay, how so? Because if ever you have the 16, let us analyze just this. Okay, this is one way to do this, but yeah, not the only way, but you can take 16s minus 2s squared, factor out the -2 and have s squared minus 8s, like this, minus 2, which is s squared minus 8s. You divide by 2, subtract the same thing. Which is s. Okay, so your, and then you have minus 4. You square this, minus, okay, if you square the minus 8, you square it. Okay, you have minus 8 divided by 2 is minus 4. You square it, it's 16. Plus 32. Plus 32. Okay, this is one way to do that, but you can also use differential calculus. You can also use differential calculus. Right, and so if we actually obviously use differential calculus, we are sure that the maximum which is the maximum velocity, is at the vertex, is at s equals 4. So the maximum velocity is going to occur when s equals 4 in this equation, because the maximum is going to occur whenever s equals 4, whenever this perfect square equals 0. In other words, we have the following: v squared. In other words, we have v squared, which is exactly 16s minus 2s squared, and right, minus 2s minus 4. Minus 2s minus 4 plus 32. And we've already said the maximum velocity is at s equals 4. So want to find the maximum velocity, which means that v squared, let's do it in green color. Well, it would mean therefore that v squared is 16s minus 2s squared, which means v squared is 16, the s is 4. Yeah, 4 squared. Ah, 16 by, okay, s is 4. Okay, so we have 16 by 4. 16 by 4 is what? It's 64. Okay, 4 squared is 16. 2 by 16 is 32. And this is 32. Okay, so let's take a look at this. What are we saying here? We're effectively saying the square of the velocity is 32, which means v squared, 32. Square root of 32. Square root of 32. Right, so we can see that the square root of 32 is 5.66 or 5.657, which is 5.66 meters per second. So we can see, therefore, that the maximum velocity, Vmax, is 5.66 meters per second. 5.66 meters per second, which means that the maximum velocity, Vmax, is 5.66 meters per second. But I mean, as I indicated, it's not the only way to the question. One way to the question is to say the square of the velocity is 16s minus 2s squared. 16s minus 2s squared. And what is this? Okay, this is the square. Okay, like so, v squared is 16s minus 2s squared. Okay, with this then, we want to find the maximum velocity. So if this is the velocity, to find its maximum, you need to find, you need to associate what exactly this would bring. So you must be in a position to look at where the maximum velocity occurs. The maximum velocity, at the maximum velocity of a particle, right, at the maximum velocity of a particle, if you know that the acceleration itself is 8 minus twice s. Okay, remember that the acceleration of a particle traveling along a straight line is this one here. And whenever the velocity squared is this, there's a part where the velocity is a maximum. Right, so wherever the velocity is a maximum, it relates to the acceleration. So the acceleration will as well change. We know that a bar is 8 minus 2s, but your acceleration is the VDT. So obviously, if acceleration is the VDT, it gives us another equation we can actually be in a position to sort of determine here. Right. It gives us exactly this aspect of reasoning. So, if this becomes the case, you can be in a position to then say, at the point where we have that we have the maximum velocity, which is what we need to determine. How would that relate to the acceleration? So obviously we need to know that the particle is traveling along a straight line and its acceleration is given by that, but therefore its square of the velocity is given by that. If its square of the velocity is given by that, and the velocity itself, its maximum, right, we can be able to, let's just stick to the first method we used, so that it would be Vmax. Vmax is 5.66. Vmax is actually 5.66. Right, it is 5.66 there. 5.66. Right, so any question or remark? Right, any question or remark there? Okay, there are too many ways so to analyze that, but let's continue and look at the next question. Let's continue and look at the next question. Express S as a function of time. We know that the acceleration, so we're looking at twice B. Is 8 minus twice S meters per second squared. Express S as a function of time. Right, so if we want to express S as a function of time, we then must be in a position to then say, first and foremost, we know that the acceleration is given by what? The acceleration is given by 8 minus twice S. If this is the case, how can we then be in a position to express S as a function of time? Let us do this together. Let's reason this out together. So there are a couple of things then that need to be taken into account. To express S as a function of time in this particular equation, what do we get? Because we know acceleration is this, but we know that acceleration is what? Is dv dt. Okay? But we know that velocity is ds dt. Is ds dt. And then now, there's something you can do here. Acceleration is d dt. There's something I want to do. What is velocity? Okay, so we have acceleration is dv dt. Right, at some point we're going to have discussions about these things and solve like a lot of questions, but yeah, we like discuss the methods, we share views, and you can share what you think about the questions as we move along. Velocity is ds dt. So acceleration is also d squared s dt squared. Wherever the acceleration is d squared s, acceleration is d squared s dt squared, which is 8 minus twice s. Like that. We need to express s as a function of time. So we have s and time in this equation. So it must be possible to express s as a function of time. Meaning d squared s is the same as 8 minus twice s dt squared. D squared s is the integral of 8 minus twice s dt squared. Okay, so that we have the integral of d squared s is the integral of this one here, 8 minus twice s dt squared. Right. And then now we get the integral of this. You can be in a position to perform the integral of this. What then is the integral of this? So the integral of the ds squared can be seen as just ds. That this is dt squared, so you're going to do the integral once, and so it's going to be exactly 8t minus, right, so you're going to have 8t because that's a constant, and then you'd have the integral of the s as the function of time, so you would have minus the integral of twice s dt squared. So let us look at these and reason this out together and see what we're able to achieve. And see what we're able to achieve here out of this. Right, and remember, we actually want to determine s as a function of time. S exactly as a function of time. And obviously, there are a couple of ways to look at this, and I'm looking at the best way to sort of be in a position to look at this. Let me see what we have got here first. If we got that v squared is this, and right, let's just use this particular equation. Let's just use v squared equals 16s minus 2s squared. It's easier. Right, that's what I'm going to use for the part B. I feel that that's going to be much easier. It's going to save us lots of time and trouble. So let us take this one. Let us take v squared equals 16s minus 2s squared. V squared equals 16s minus 2s squared. It's 16s minus 2s squared. V squared is equal to 16s minus 2s squared. It's 16s minus 2s squared. 16s minus 2s squared. Okay, let's take this one out. Now, this can be seen as v bar, the square root of 16s minus 2s squared. Okay, put plus or minus, please. So this is actually this, and you put plus or minus here. V in general, it's plus or minus the square root of this. You want to find x as a function of time, but the velocity is ds dt. 16s minus 2s squared. Okay, let's analyze this together. Right, if ever we have this particular expression, if ever you have ds dt, considering maybe the positive for a start, 16s 2s squared, ds divided by, we divide by this one, 16s minus 2s squared equals dt. Equals dt. And that is the answer. We've already got the answer. So now, with this here, you need to remember the rules of integration. You need to remember the rules of integration. What is the integral of the following? Okay, shall get to that just in a split second. So we have ds. If this is the case, there's something we need to know about the integral of dt, or normally you can put dx, doesn't matter. dt, yeah, the dx is very popular with the dx. So the integral of dx divided by the square root of 1 minus x squared. What is this integral here? This integral is the arcsine of x plus c. Arcsine of x plus c. Arcsine of x plus c. Okay, let's check this one. Check these. I want to create more space here. So I'm going to remove some of this and create more space. We are not in a hurry. We are solving the third questions. So we want to make sure that we sort of are able to sort of understand what the thirds are. Okay, yeah, we need to get to a practice discussion on these things. Trying to save as much space as possible. I'm trying to, yeah, okay, I should have, doesn't matter. So I'm gonna do the following. Okay, take a look at this. A equals 8 minus 2s. Yeah, okay. Yeah, that's fine. But I want to go straight to the point of the v squared. So v squared is 16s minus 2s squared, something like this. 16s minus 2s squared, yeah. V squared is equal to 16s minus 2s squared. And we have seen therefore that we can write v as plus or minus the square root. We can take the positive ds dt is plus or minus 16s minus 2s squared. Taking the positive of this, or negative of this, taking the positive. We have ds equals the square root of 16s minus 2s squared ds dt, excuse me. Okay, choose, oh, that is choosing the positive square root. Choosing the positive square root. So now we get here, we have ds (16s minus 2s squared). Oh, okay, equals dt. dt. Let us find the integral of this. So the integral of this can be found using grade 11, completion of the square under the square root. Let us complete the square here under the square root. We've already done it. Let me see. You can get, don't want us to waste time there. Okay, because the 16 minus 16s, the 16s minus 2s squared, 16s minus 2s squared is minus 2 s minus 4 squared plus 32. We've already seen that. 16s minus 2 squared is already equal to minus 2s minus 4 squared plus 32. Let's write that one down. (16s minus 2 squared minus 2 s minus 4 squared plus 32. Okay. Right. So in other words, we have ds over Okay, whenever we have 16 minus 2s squared, we've seen that in the blue color, we can write this one as that. In particular, you can write it as 32 minus 2s minus 4 squared dt, like that. We can factor out the square root of 2 from, we can factor out 2 from the denominator. Factoring out 2, you have 16 s minus 4 dt. ds 2 16 minus s minus 4 squared equals dt. S minus 4. With this. Okay. So the square root of 2 that comes out of this, but you can write ds over the square root of 16 minus s minus 4 squared is the square root of 2 dt. Let us find the integral of this. Let us find the integral of this. Like I said earlier, the integral of from the calculus class is the integral of 1 minus x squared like this is x sine x plus c. So this one, okay, but now you'd have to take out the 4 again. So that this thing here becomes exactly a 1 minus. A 1 minus. Right, so for simplicity, I'm going to write a certain result here. I'm going to spend time on the techniques of integration so that you can learn the methods of integration. But here we're just, using the results. So I would say, okay. I would say 1 over the square root of exactly 16. We're going to write the result. 16 minus. I'm also going to have a couple of ways to sort of, show these particular techniques and discuss them. Okay, we are in a relaxed mood here. We're not in a hurry for anything. So if this is the case, in view of this result and the fact that here you can factor out 16, getting ds over 16, which is 1 minus s minus 4 out of 4. Okay, because the first square is 16. So this is the same, which is the square root of 2 dt. Take a look. Okay, if this is the case, is the s divided by the square root. Okay, the square root of 16 is 4. 1 minus s over 4 minus 1 squared. The square root of 2 dt. Okay. So what do we have here? Okay, so it's it becomes sort of exactly the same thing there as that. So you have the 1 minus under the square root, and then it's a 4 here. There's a 4. So that now you can take the integral of this, the integral of this. So you have 1 over 4, the integral of this, which is arcsine. Let's do green color. Yeah, let's do green color. So now this is going to be exactly 1/4. Okay, there's going to be 1/4 there. Right. Let me just do this to cut long story short and to avoid lots of errors. Right, we had to spend time, but the integral of this is the same as the arcsine. One quarter s minus 1. Okay, which is the integral of this square root of 2t plus so if this is actually what you get, and then now obviously you can add an arbitrary constant c of integration in general. Let's add that one. Right, so if this is the case, in which case you can add that. And you can similarly decide it is 0, which means arcsine of that. Watch what the examiner or the person who came up with this question, the author of the question was imagining maybe possibly at the beginning, etc., etc. So at which the constant could be considered 0. Okay, so in mathematics then, in the science, if ever you have arcsine x equals something y, what is this? Arcsine x equals y, which means that x is sine y. X equals sine y. So now, if arcsine equals this, then the sign can go to the other side like this. So you can do that. Which is the sine of the square root of 2t. Right, which is the sine of the square root of 2t. Square root of 2t. Like that. A quarter s is therefore the same as square root of 2t plus 1. So you can move the 1 across. So it becomes a plus 1. And then now we can multiply through by 4 both sides. 4 times 1/4 s. The square root of 2t plus 1. Which is 4 the sine of the square root of 2t. And clearly this is the answer. And also, I mean, you can state it as saying that s is a function of t is 4 the sine of the square root of 2t plus 4. Note that the integral of this is exactly that. Okay, these integration techniques, you can always discuss them together. But here it is based on the fact that the integral of d dx of 1 minus that is actually arcsine that. But you can spend some time trying to establish that. So please ponder, think about this, and sort of make sure you understand what is happening. And you can actually be in a position to make informed decisions about the tasks, but also your interpretation of these questions is pretty much within the ambit of the expected realms of reasoning. Right. Obviously, I mean, we are not done yet, and we're doing these questions. We're in a very relaxed mood, trying to analyze this question. We're not running here. We're not in a haste for anything. We shall split this into a series of like 2 discussions. I mean, we shall have another discussion later on today. So yeah, we're good. We're so good. But let us look at the next question right now. What is the next question? A particle is moving along a straight line with an initial velocity of 6 meters per second when it is subject to a deceleration of a equals minus 1.5 the square root of v plus 1 meters per second squared, where v is in meters per second. Determine how far it travels before it stops. How much time does it take? Okay, let us look at these together. Let us look at these together. If this particle is moving along a straight line, moving along a straight line with an initial velocity of 6 meters per second when it's subject to a deceleration, a equals that, where v is, the deceleration that is spoken about here is negative acceleration, v plus 1 meters per second square. So we note, therefore, that at this point, the acceleration, we note that the acceleration and velocity are related by, okay, are related by this formula. So this formula relates both the acceleration and the velocity. Okay. And so, but acceleration we know it's dv dt. V plus 1 meters per second. Meters per second. Meters per second. Okay, we have this. Now, we need to determine how far it travels before it stops. So now, we continue to analyze this. We continue to analyze this. Okay, if this is the case, we want to know how far it travels before it stops. All right, at the moment that it stops, then its velocity is going to be 0. But how far, then we're going to get how far. But now, this is an equation. I would love to really work hand in hand with you and practice more of this and discuss more. I need to test your skill to tackle these questions and make sure you can interpret the terms of the questions. Okay, if we cross multiply here, this is the v over the square root of v plus 1 is minus 1.5 dt. Okay, this integral of this, the integral of this. So first things first, this will be the integral of, this one you can take it to the top. So you v plus 1 minus 1/2 equals the integral minus 1.5, the integral of dt. The integral of v plus 1 to the minus 1/2 dv minus 1.5, the integral of dt. Take a look at this. Take a look at this. What is the integral of this? Use u substitution because x to the power n dx in terms of the principles of integration is 1 over n plus 1 x to the n plus 1 plus c. 2, v plus 1 to the power 1/2 to the power 1/2 minus 1.5 t. $1.5t. $1.5t. Okay, let's take a look at this. Let's take a look at this. Okay, if you integrate this one, because you have integrated this, okay, now look, the integral of this one is to the power -1/2. For if x is to the -1/2 dx, it is the same as x to the -1/2 plus 1. You divide by -1/2 plus 1 plus c. Okay, 1 minus half is half. It's going to be 1/2, but the power 1 minus 1/2 is 1/2 divided by 1 minus 1/2 is 1/2 plus c. 2 x to the 1/2 plus c. So this is what we get. Because now you take the power minus 1/2, you add 1. Then you divide by minus 1/2 plus 1 plus c. 1 minus 1/2 is 1/2, and then divide by 1/2. And then this one is 2x to the 1/2. So please, we need to work together. We need to try and solve the questions. We need to work. Discuss. I need to check. I need to see how you reason this out, so I can be sure that you have the kind of skill by the end of our discussion. But I know that, you see, with the university students, we respect them a lot. We don't engage them too much. That is why the lecturers just go to class and talk, and go back to their class, to their offices. That's what they do, because, but yeah, it's not so good. We need to engage the students. Okay, let's see what we get here. So we can add C, arbitrary constant of integration. Let's check. Let us check. Okay, we get to this point. So now when we go to this point, what actually do we need? But there's an initial condition. A particle is moving along a straight line with an initial velocity of 6 meters per second. So initial velocity. What is the initial velocity? 6 meters per second. So this initial velocity of 6 meters per second, it is initial velocity. Because it is initial velocity, it is a time 0. Right, so we have 2, the initial velocity is 6, so wherever it is v, you put 6 plus 1, and then you apply the square root, minus 1.5, and you multiply by 0 time, and equals c. So 1.5 by 0, and this is 7 to the 1/2 c. C, it's double the square root of 7. That is it. C is double the square root of 7. Okay. We found the arbitrary constant of integration C from the initial conditions that the initial velocity is 6 meters per second when it's subject to a deceleration of this. But you see, this is the initial velocity of 6 meters per second at time 0, and hence initial. We press on. So wherever there is C here, we can put 2 double the square root of 7. 2 the square root of 7. So we have 2 with V plus 1 to the power 1/2 minus 1.5 T plus 2 the square root of 7. Okay? Okay. Now with this, determine how far it travels before it comes to a stop. Okay, let us analyze these together and see what it means. Divide by 2. Divide by 2. So with minus 1.5 T divide by 2, but if you divide by 2 here, it becomes just the square root of 7. Like that. Okay? We square both sides. Square the left. Square the right. So you square both sides. Upon squaring both sides, you have V plus 1 is equal to, okay, 1.5 if you divide it by, okay, 1.5 is 3 out of 2. You divide it by 2 is the same as multiply by 1/2, so it's minus 3 over 4. Minus 3 over 4 is minus 0.75. So in other words, the minus 1.5 divided by 2 is actually minus 0.75 the time plus the square root of 7, and then you square everything. The times when we shall spend lots of time discussing 3 questions, but they are like going deep into trying to understand the mechanics of this, the kinematics part of this. It means, therefore, at this point, we are confident to say V is minus 0.75 T plus the square root of 7 squared minus 1. Take a look. Take a look. Determine how far it travels before it stops. So a stop implies that the velocity became 0. Whenever a stop means the velocity, because if ever it stopped, then it means that it's not moving, so its velocity is 0, which means 0 is equal to minus 0.75 T plus the square root of 7, and then you square this minus 1. Minus 0.75 T plus the square root of 7 squared. Okay, this is a square. This is a square, meaning that you can take the square root. In general, it's plus or minus. There's the square root. In general, it's plus or minus. Well, we can determine if only it's plus sometimes. Okay, because it's time here. So in the end, the time must be positive. So we want to solve for time. So which means that it's plus or minus 1 because the square root of 1 is 1. Okay, you take the square root here, it becomes, the square goes away. You can write something like this. Either way, this is going to work. Which means you have plus or minus 1 minus the square root of 7, 0.75 T. Okay. Okay, plus or minus. minus 0.75. So you divide. You divide. Okay. Yeah, but in the end, yeah, we need a positive time. So we're going to divide by minus 0.75t. 0.75 only, and then it equals t. Okay, but now reason with me because, yeah, this is just interesting. Reason with me because this is very, very interesting. Reason with me because this is very, very interesting. Okay, which one is going to produce the positive time here? So therefore, t is two values. We take 1 minus the square root of 7 minus 0.75, or t is minus 1 minus the square root of 7 divided by minus 0.75. Okay, let's check. So you have 1 minus the square root of 7 divided by negative 0.75. Which is 2.19. 2.19 seconds. So here we're going to write 2.19 seconds, or t equals, very interesting. See what you get here. Let's do this one. So you have 1 plus the square root of 7, 0.75. 4.86. 4.86 seconds. 4.86 seconds. Okay, we have this. Okay, let's check. Let us check. Let us check. Okay, so, I mean, we're getting two possible times here. And this is the time that the examiner, the author registered. And this time that is registered is the time whenever a positive was chosen for the 1. So in other words, the author of the book just considered everything positive here. And having considered the 1 positive and was able to deal with the positive, and positive produced this one here. Meaning that obviously you shall take this out and consider that the time is 2.19 seconds. So we need to determine how far it travels before it stops. So yeah, we said that when it stops, then the velocity is 0. At a stop, the velocity is 0. Yeah. But how far? So we need a displacement. How far we need the displacement? What is the displacement? Right. We need the displacement for how far? So You see, the notion of how far is very, very important. What is the speed? Look at the speed. V is equal to minus 0.75, the square root of 7 minus 1. Minus 0.75 t plus the square root of 7. Squared minus 1. Okay, we are taking it from here. We're taking it from here. Like this, minus 0.75 t plus square root of 7 squared minus 1. We're saying determine how far it travels before it actually starts. Right, so we know that velocity is ds dt. Right, you can write it on the side and then obviously substitute there. But we know that velocity is ds dt. So that in the present velocity here, I would have ds dt, which is minus 0.75 t plus the square root of 7. You square everything minus 1. I'm going to give you some part calculations to do sometimes. Like part calculations. Part calculations. Okay. Right. 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 Okay, we continue. Okay, here we need to answer the question. How far? Determine how far it travels before it stops. Right. We continue. Determine how far it travels before it stops. Determine how far it travels before it stops. Determine how far it travels before it stops. Okay, yeah. So we're good. Let's do this one, please. Okay, we here. We need to solve for s because how far its displacement. So we need to know the displacement. So how far is how many meters? Okay, we shall get this answer, but we need to just perform some manipulations in a little bit. Okay, we're continuing, please. Okay, we're good. Let's do this. So ds is minus 0. Okay, I said the sessions we shall work together and talk to each other. I think in the next session. In the next section, we shall agree. So yeah, the dt we gotta of course multiply and look at this. We manipulate. Right. Okay, we are continuing, please. What do we get here? Right. Right. Okay. Let us deal with this. Now we need to find the integral of this. What is the integral of this? Okay, let's check. Right, to find the integral of this, first things first, we need to find the integral of the s. There are too many ways. The integral of minus 0.75t plus the square root of 7 u square minus 1 dt. Okay. Which means the integral of ds. So you factor out the minus 0.75 and then you square it. So it is minus 0.75 that you square. And then now after you factor that out of this, okay, let us separate. It is not integration by parts. It is not integration by parts, but we know that the integral of ds, it's the integral of minus 0.75 t plus the square root of 7 minus 1 dt. Okay, so we can integrate ds. Okay, we got, so we're continuing here with the integration. Just need to integrate this one. So um uh, uh-huh. Right. Righty. Righty. Okay, let's check. Okay, we're here. Okay, we're good. Now let's do this. So this one here is going to be the integral of term by term. It's not integration by parts. So it's this one. Okay, integration by parts. What is integration by parts? Let me talk about it. You might have done it already. In the mainstream, in the pure maths class. Okay, so there's something called integration by parts. It's the first calculus thing you do at your, maybe it's the second module. Okay, because the first one is like differentiation and limits and things. Right, this integration by parts. The integral of u dv minus the integral of v du dt. Okay. So what do we get here? Okay, so it is minus 0.75, which you take out of the brackets. You like factorize, but if you take the minus 0.75 out of the brackets, you get t minus the square root of 7, then 0.75, and then you square everything, and then you put dt minus the integral of this. That's just factorization, these. School arithmetic. So now let us do the good. So the integral of the ds is going to be s vector. And then the minus 0.75, you square everything. And then when you get to this point, so this one is the same rule of integration. So if you have here the integral of x to the power n dx is 1 over n plus 1, x to the power n plus 1 plus c. So you have 1/3 here, 1/3 here, t minus the square root of this one 0.75. We need to practice these kinds of questions. Minus t plus c. They're all based on, okay, I was saying this is integration by parts, but we're not doing it. The fact that we're integrating these parts, and then integrating this part, because you had like two parts. Well, doesn't suggest integration by parts, this one. All right, so we good, but we have this. Wow. What have we just got? We've got the following. We've got vector s is minus 0.75 all squared out of 3 t minus the square root of 7, 0.75, you square it, you minus t plus c. Okay. Determine how far. We determined the time whenever it stops. We saw that the time was 2.19. So now how far? Now this is the displacement formula or equation. So we good. How far? 0.75 negative all squared divided by 3, 2.19, the square root of 7, 0.75, you square, minus 2.19. Okay, I'm sure we can admit that C0. Okay, why do I agree? I would admit, yes, we admit that C0 because the way we're integrating this right now, we are integrating this from 0. You can put the integral here. But you see, the minute we put the integral here, we can put the integral from 0 to the time 2.19. 0. Okay. Okay, I need to check this carefully. Need to check this very, very carefully. Okay, because we have limits of integration, we can actually admit that this constant is 0. Just take it as 0, because this kind of an integral is called the definite integral, just to avoid complications. Definite integral, the definite integral. So, yeah, it has limits of integration. So we're gonna just substitute the time there. Minus 0.75 squared out of 3. Yeah, we substituted that already, by the way, seeing that. Wherever that is t, we've already put that 2.19, so are we good? Let us do it with the calculator. Check what the calculator is going to give us. Right. Minus 0.75. You square everything, you divide by 3. 2.19. You minus, the square root of 7. 75, you close the bracket. Minus 2.19. Let's see what is happening here. Okay, need to just cross check this one. Sorry, it's a cube here. Okay, because when you integrate it, here we got a cube. And plus 1 at the top, so this must be a cube. Wondering why that is producing a negative. So that This is the cube. Check that. Cube, cube. Okay, it must work out now. Check. Okay, check. So this is minus 0.75. You close and then you square it. Divided by 3. 2.19. You subtract. Square root of 7 out of 0.75. You close and you square up. You cube, please. You cube. And then you subtract 2.19. All right. Let's see what we're getting here. Need to check what we're getting here. Need to see why this is producing a negative. Need to see why this is producing a negative. So, let me see. Let me see. See. Check. Right, so if we check here, we go get exactly that part. Okay, we're checking. I want to check why is producing an answer that is a bit weird. Okay. I want to check why is producing an answer that's a little bit weird. Answer that's a little bit weird. Okay. Right. Okay, I'll get to the bottom of this. Now, there are two things I'm sure that the examiner looked at in this question, and what are they? Because if you use a calculator here, you can get to the bottom of this. But if you use a calculator here, first and foremost, you can notice that there is a small discrepancy in the behavior of this function. So which means that if you put the open bracket, you punch this, yeah, I'm going to just get to the bottom of this. Is exactly what I was looking at. So 0.75, you close, you square, you divide 3. You put 2.19, you minus the square root of 7, you put 0.75, you square, you minus 2.19. That is fine. But obviously something we need to take into account here. It is that there are two velocities that are competing velocities. The initial velocity of the particle and how long it takes. So the initial velocity was 6 meters per second. So please take filter that in. So if here now you are integrating, okay, it's an engineer in making. We're starting 6. We're starting at 6. Right, we're performing the integration, but the integration right now is going to be starting from 6 to the amount of time. What will the amount of time be at this point? What will the amount of time be at this point? So you would then say it starts from 6 to how long it takes. 2.19 to come to a stop. From 6 plus 2.19. This is what you can do. 6 to 6 plus 2.19. 6, then 6 plus 2.19. Wow, obviously, I mean, you can say it's 6 and then 8.19. Okay, so that here it's 6 to 8.19. Okay. Initial velocity is 6 to 8.19. So now let's perform some transformation here. Okay, right. So you're gonna have the following. Okay, let's do minus 0.75, you square it. Divided by 3, then you have 8.19, and then the square root of 7, and then 0.75, and then you square this. 8.19 minus, okay, let's do in green color. Initial velocity 6. No, there's a mistake here. It must be from initial times 0, because yes, the initial velocity was 0, but the initial time was 0. Okay, just check that. The initial time was 0. The initial time was exactly 0. I'm trying to establish why that. I'm sure I'll get to the bottom of why that is the case. Let me see. I want to see. Yeah. Mm-hmm. 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 Okay, I'm trying to check. The initial time was 0, although the velocity was 6. But yeah, the time was 0. Yeah, but yeah, I'm trying to discover why this is not quite working out. I'm trying to discover why this is not working out, because it must work out when we say the time is 2.19. Right, the time must just be 2.19. 2.19. It's 0, time, beginning, but velocity 6. Okay, and also, okay, obviously this is cubed from the integration. Cubed from the integration. Right, I need to check this. Let's check again with the calculator. We're supposed to work out, but let me see what this is doing. Trying to check if there's no mistake in the document. 0.75, and then 0.75, you square it, you divide by 3, you multiply 2.19 minus the square root of 7, 0. Okay, let me see. Let me see what is happening here. Because this was plus, so it's gonna be minus. Let's see, it was plus, so it's gonna be minus. I'm trying to really get to the bottom of why the it's not just working out easily. Y is not working out easily. You have this, and then you divide by 2. Divide by 2. Okay, but you add. Divide by 2. Divide by 2. Divide by 2. So it's going to be minus. It's going to be minus. The 1 is plus, and then it's going to be minus. Okay. Going to be exactly minus. Okay, I'm trying to establish why, if we're punching this correctly on the calculator. Just a second. Check again. Minus. Okay, so that's going to be like a minus 0.75. 0.75, I believe it's also correct itself. You square this, divide by 3. Multiplied by 2.19 is minus the square root of 7 divided by 0.75. I believe the 0.75 itself is correct. 3 out of 4 is exactly that. You raise it to a cube. Minus 2.19. So it's giving us a negative result. It's giving us a negative result. But obviously, there are 2 possible values of the time. Let me check. There's also 4.86. Investigate that one. 4.86, which I believe is much larger. 4.86. So in other words, you can put in the place of the time here and put 4.86. I'm trying to investigate. I'm trying to investigate to see if there's a small typo that I need to rectify. So you have the screen and the calculator. Okay, so that would be, for example, open bracket minus 0.75. You close and you square everything. Divide by 3. Open bracket. Okay, now we're doing 4.86. Okay, 4.86. Minus, it's going to be negative still. Okay, so you have 7 here. 0.753 minus 4.86. Okay, you can see it's actually yielding a negative result. Right. So double check this. Right, need to check exactly. I'm not expecting this. I'm not expecting that, but let me see if there's a sign issue somewhere. Let me see if there's a sign issue. I'm going to track it with this, and you go to this point. Okay, go to this. Okay, so this must be fine. I'm trying to check and see if there's a sign issue. Okay, you see the initial velocity is 6 meters per second at time 0. Okay. Minus that, yeah. And this 6 plus 1 is 7. So it must be correct up to this point of the time t equals 2.19. I'm trying to see if there's a small mistake because it must work out to 5.59. Right, so 2.19. All right. Mm-hmm. Try to check, please. Just give me a split second. Right, I'm trying to check the arithmetic. Okay, I can just do it differently, but yeah, it's the same thing. I'm trying to investigate and get to the bottom of this. Okay, one thing you can do. Okay, I'm just gonna use a slightly different method. I'm trying to see if something is a little bit amiss here. Okay. It looks pretty fine, but yeah, they can just be that number that is messing us around. So for the 5.59 meters. Right, we're gonna be really quite quick now. Gonna be really quick. Yeah, there's too many ways to do that. But yeah, I'm not expecting a huge difference in the result. But it's very, very interesting though. So now let's get to this point. Let's get exactly to these points. We've already got the time, that the time is 2.19. Okay, we've got the time to be 2.19. So I want us to, you got the time to be 2.19, which is fine, which is what the examiner got. But let's actually therefore get to the displacement. We answer the question now, how far? Right, we remember that acceleration is the v dt. Right, we know that acceleration is itself is the v dt. Right, so if acceleration itself is the v dt, we can be in a position to obtain the the displacements. All right, you can be in a position to obtain the displacement. So if we take note of the fact that I think that maybe that is the issue. Okay. Right. So acceleration is that. So this is an acceleration equation. So which means that if this is an acceleration equation, it is A, which is the v dt, which is minus 1.5 v plus 1. Okay, I'm trying to get to the bottom why that was the case. So now, obviously, at this point, we have the v, which is minus 1.5, the square root of v plus 1. I think we did that. Okay, let us, now, we have this, and we can be able to find the velocity. Right, we can be able to find the velocity. And we find the velocity by integration, and then we integrate again. So we need to integrate twice. Right, and then now we have the integral dv minus 1.5, the integral of this one. Okay, the v plus 1, I mean, you can write it as v plus 1 to the power 1/2. Because that is the square root. Minus 1.5. Yeah, I need to do separation of variables, please. Right, we need to do separation of variables. Which means we have the v dt, and then you perform the integral here. like that. Meaning that now the integral is going to be exactly v plus 1. You can take it to the top. Fine. Okay, let's check here. Now you integrate this one, it becomes 2 v plus 1 squared. No. Okay, you divide by 1 plus this, but you raise it to the power 1 plus that, which is 1/2, because 1 plus this, that is 1 minus 1/2 is 1/2. Let's see. Like that. And at this point, we have exactly this. But we reasoned together that initially the velocity was 6 and the time was 0. 6 meters per second. So you have 6 plus 1. And the time was 0. Meaning c is equal to 2 times the square root of 6 plus 1. It's indeed 7 square root. Right. We're good. With this, then it means that we can come to this equation and say v plus 1 to the 1/2 equals minus 1.5 t plus 2 to the square root of 7. Check this. V plus 1 1/2 equals minus 1.5 t plus 2 times the square root of 7. Okay, so this is what we have. And then now we want to find the displacement to answer how far, because I'm trying to track. I try to see if there is a small error that sort of affected the answer. So you have this one here, and you have 2 to the square root of 7, and you divide by 2. That's algebra. And you square both sides of this. You square both sides. T here. You square like this. Meaning v plus 1. Okay, check. Okay, and then this is exactly what you're getting. Okay, if you square these, you can write differently now. You have 1/4. That's going to come out 2 squared. It's going to be 1/4. Okay, you can expand this now and have, for instance, if you have 1.5 is minus 3 over 2, and then you square it. 9 over 4 t squared. Next, you multiply 2 with minus 3 over 2 and multiply by 2 to the square root of 7. 2 times minus 3 over 2, yeah, that. 2 cancels, minus 6 to the square root of 7, t. Plus 4 by 7, which is 28. Like that. Okay, now if you square this is v plus 1, and then it means that we have v plus 1. Just trying to see, use a different method and to see if there's a small error in the calculations. So obviously then you have 1/4. 9 over 4 t squared. Check. Minus 6 to the square root of 7t. Plus 28. Okay. Right, so you see. And then you can say v bar equals, okay, multiply through by the 1/4. Okay. 4 by 4 is 16 t squared. 6 to the square root of 7 divided by 4t plus, if you divide 28 by 4, you get a 7, but you subtract 1. 9 over 16 t squared, 6 over 4 the square root of t plus 6. Right, if you take t equals that, okay, this is velocity. Huh? You see? Oh, yes. Yeah, I think that's the reason. This is velocity. But I want to get the displacements. Let's see where the error was here. So let's get the displacement. So we know that the velocity is ds dt. 9 out of 16 t squared minus 16 out of 4 the square root of 7t plus 6. Which means that s is, yeah, you find the integral of this right now. Okay, let's do this. Yeah, I think the error was there. So we sort of, okay, let's see. Fully, we just checked it. All right, so with ds, I mean, there are many ways of doing this. So ds, we cross multiply here. 9 out of 16 t squared, 6 out of 4 the square root of 7t plus 6, and then you put dt. Square root, what is it? Integral. Let's integrate this. Okay, 10 by 10. Right, so you have 9 out of 16. The integral of the t squared is t cubed out of 3. 6 out of 4, the square root of 7. The integral of t is t squared out of 2. 6t. So now we're going to do this, and we're going to 3 times, because I mean times into 9. 3 times 16 t cubed. 3 out of 2. Yeah. Okay, there's another 2 here. 3 out of 2, and then it's 3 out of 4. Check. Check this out. Okay, so it's 3 out of 4. Because this is 3 out of 2, dividing 6 and 4. 3 out of 2. But there's a 2, giving us a 4. 7 t squared plus 6t. Okay, check. All right. It's just some little problem here. So now, if we put t equals this one, so we have 3 out of 16, then you put 2.19, you cube it. 3 out of 4, the square root of 7, you put 2.19, you square it. 6, and then you put 2.19, and then, yeah. Okay, let's check how far this is going to take us. We're expecting the result to be the one who gets. Check. 3 out of 16. 3 out of 16, then you have 2.19. You cube it. Minus 3 out of 4 times the square root of 7. Yep. Times 2.19, you square it. Plus 6 times 2.19. Yay! We got it. I'm wondering why it does not. Okay. Right, so there it is. There it is. So it is 5.59 is it was obtained. 5.59 meters. 5.59 meters. So we're getting exactly S equals 5.59 meters. Okay, we should have obtained these a while ago, but maybe there was a small error in the algebra. But yeah, there it is. Any question? This is enough for now. Any question? No question. So we shall return again and do more. and do more. 4, 5, 6. We did 3, we're going to do 3. We did 3, we're going to do 3 again. And finish, and then we can do more. Other questions?